Hello, warriors of math. It's time for us to tackle homework 1-10, where we're working on adding and subtracting mixed numbers. I picked a few problems for you to zero in on and get a little coaching from me. Let's look at number 1 together. Number 1 asks us to take 1 2/5 from the number 3. Notice how I've lined it up. We want to line it up really kind of by place value. The fraction part where the fraction is, the whole number part where the whole number part is. But here's where we have a problem. We need some kind of fraction to subtract 2/5 from, which means we need to take some value from this whole number part. How about we'll take 1 whole, and we need to bring it over to the fractional part. The question is, what are we going to put as a fraction? Well, for that, I want to pay attention to my other fraction. I have 2/5. So fifths is the size units or pieces that we're working with. Well, let's keep that the same. It'll make everything easier. So that 1 whole, I'm going to convert to 5/5 because that is the equivalent. Oops, here we go. Sorry. Now I simply subtract by place value. 5/5 take away 2/5, 3/5. And 2 take away 1, 1. Now the last question I always ask myself is, can I simplify? And I look at the 3/5 and I think, there's no common factor except 1 that I can divide into 3 and 5 without getting into all kinds of issues. So the answer is no. This is simplest form of 1 in fifths. All right, now let's take a look at an addition problem. Number 4 asks us to add 4 5/6 to 6/7. I can already see both of my fractions are greater than 1/2, so I can tell I'm going to end up with a fraction greater than 1. But before I can add, I need to make sure that my units or my pieces are the same size, and I'm going to do that through finding a common multiple. Remember, we find a common multiple by looking at the multiples of each of the denominators and finding the lowest common multiple if we can. It makes life easier. In this case, the lowest common multiple, if we keep skip counting, is 42. Now I need to think to myself, how do I get from 7 to 42? 7 times, 6. If that's what's happening in the denominator, if I'm breaking those sevenths into 6 equal parts, then I'm going to do the same to the numerator. 6 times 6 is 36. Now 5/6, I need to figure out how many 6 am I what am I going to have to do to get to 42? Well, again, I'm going to be splitting each of those 6, 7 different ways because 6 times 7 is 42. Whatever I do to the denominator, I do the same to the numerator in this case. 5 times 7 is 35. Oh, yeah. So now I just add the way I add. Now over on the side, I just want to make sure that I don't rush and add something in my head incorrectly. So I'm going to take that 35 and 36 and add them over here. I'm getting 71. That makes sense to me. So I've got 71 over 42, and 4 plus nothing is 4. This cannot be my answer. And the reason it cannot be my answer is because a mixed number should have all the whole number parts where the whole number is. When I look at that fraction, I see it's greater than 1. That means there's some whole number in there that I've got to pull out. So that's what I'm going to do. I'm going to take that 71 over 42, and I'm going to say, okay, well, if 42 is my denominator, then I need to figure out, what would equal 1 whole with that denominator? Well, 1 whole is all the pieces, so 42 out of 42. But, what does that leave me from here? Well, let's do a little bit of quick calculating to find out. Looks like it leaves me 29. Well, 29 out of 42 isn't going to make another whole. So what does that show me? Well, it shows me that if I break apart this fraction greater than 1, then I've got 1 whole in there plus this fraction part as well. So this is what I need to put back together. 4 plus 1 is 5, and 29 over 42. And of course I have to ask myself, is this in simplest form? And I can run through the numbers. 2 won't go into both, 3 is not going into both. How about 4? No. 5? No. 6? No. 7? No. 8? No. Nope. I feel pretty confident that I'm at simplest form here. So I'm going to move on. Let's look at number 8. Number 8 is going to give us a chance maybe to practice some of the pieces in subtraction that can really get to us, that ungrouping and regrouping to be able to subtract correctly. But first, I notice I've got 2 different size units I'm working with, and I need to change that to make some equivalent fractions. If I skip count, what I'm going to find is 20 is my lowest common multiple. If I use 20, well, 9/20 stays 9/20 because, hey, we didn't change anything. Same size pieces. But 1/4, we're making a lot smaller pieces here. We're going to have to split each of those fourths 5 ways because 4 times 5 is 20. Up here, I have to do the same. Well, that's a funky multiplication sign. 1 times 5 is 5. Well, good for us, but we have a problem. Look at those numerators. 5, take away 9. If I've only got 5 of something, I can't take 9 away. I'm going to need more value in my top fraction. Where am I going to get that value? And I'm going to want it to be in 20ths, because that's what I'm counting in now. Well, I'm going to get it over here. I'm going to take 1 whole from the whole number part of my mixed number, and I'm going to bring it boop, 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 right over here. But I don't need a whole number, I need a fraction. 1 whole equals how many 20ths? Well, it's the whole thing, so it would be 20 20ths. Here's where I know a lot of folks rush and forget. We've got to add what we had to what we have moved over into the fractional place value. 20 plus 5, 25. And now I can do my subtraction. 25 take away 9. I do this 25 take away 10, which would be 15, plus 1, 16. You can do it whatever way you like. And 7 take away 3 is 4. Oh, that looks so great. I'm feeling awesome. I've got another question, though. I have to ask, is this in simplest form? And when I look at 16 and 20, they're both even numbers, so I know I can at least divide them both by 2 to simplify that fraction. But I wonder if there's a higher number. I could save myself some work. 3 won't work. 3 doesn't go into 16 or 20. What about 4? Well, I know 4 times 4 is 16. 4 times 5 is 20. So I can use 4 for sure. I got to remember to keep that whole number because it's still part of that simpler form of this mixed number. 16 divided by 4 is 4. 20 divided by 4 is 5. Now I'm looking at 4 and 4/5, and that is simplest form in my book. All right, here we are. Last one we're going to work on together. Number 10 says the Taylors have 4 dogs. Molly eats 4.5 cups of food each day. Roscoe eats 3 2/3 cups. Milo eats 1 3/4 cups. And Fifi eats 3/4 of a cup. How much do the Taylors' dogs eat each day all together? All together tells me I need to add these up. Well, this is a lot, but I bet I could still use the same strategy that I've used before. I could add them kind of do 2 and then add another one and add another one. There's nothing wrong with that strategy. I'm going to try to get a little fancy. I need to see if I can find a common multiple for 2, 3, and 4. 2 and 4, 6, 3, 6, 9, 4, 8, 12. Not yet, but I have a good feeling because I know my math facts. 8, 10, 12, 3, 6, 9, 12. Ha! I can make equivalent fractions with a common denominator that we can add things easily with. I'm going to start at the bottom, 3/4. I know that 4 times 3 is 12. Same with the numerator. And again, this is 3/4 again, so I can just put 9/12 there because I just did that math. Going from 2/3, 3 times 4 is 12. Numerator, do the same. 2 times 4 is 8. 1/2. I know that 2 times 6 is 12. Same, 1 times 6, 6. Now I'm going to have a really crazy fraction greater than 1, but we can handle it. 6 plus 8, 14, plus 9, 23, plus 9 again, 32. Does that sound right? I feel like I should double check. Whether I double check in my head or I double check by doing the math on the side of my paper, or I double check with a calculator. All of these things will work. Oh, I'm feeling good about it. And I don't want to forget my whole number part, 4, 5, 6, 7, and 8. Well, I have a sum, but it's definitely not in simplest form. It's not in a very easily communicated number here. So let's see what we can do. This time, let's take that 32/12 and let's use division to pull that whole number out. We've talked about both. We've used both. So I'm going to take that 32/12 and I'm going to say, okay, numerator divided by denominator. How many 12s are in 32? Well, if I know my 12s, 12, 24, 36, 3 is too many. So I can pull out 2 whole groups of 12. And that leaves me with 8 left over out of a potential group of 12 that I didn't make. Remember, that means that we have a fractional remainder of 8/12. And already I'm thinking 8/12. Uh-oh, those are both even. I bet I can simplify that. I could simplify it with 2 and 2 again, or I can divide both of these by, 4. 4 sounds more efficient. 8 divided by 4, 12 divided by 4. This is not the final answer because we've got our friend 8 over here. We need to add this on to that. 8 plus 2 is 10, and then we have 2/3 as part of that number. If it asks how much, well, how much means this is maybe measurable in some way. When I look at the story problem, I see that all the food is measured in cups. So I give context to the number, cups. I hope this was helpful. Remember, you eat a mammoth one chunk at a time. Take each thing a step at a time. Don't be afraid to rewatch, slow down, and pause because, hey, you can make me pause here.